today's video, we're going to be going over the basics of electrical circuits. So here's an example of a circuit that is a computer chip. So you can see that this one is a really complex circuit, but in this video, we're not going to be going in this type of circuits. So we're going to see a little more simpler ones so we can understand the basics of electrical circuits. So in this video, what are we going to discuss? We're first going to go over what is an electrical circuit, so something that will look like this. Second, we're going to go over what a series circuit is. So a series circuit is a type of electrical circuit. And then also third, we're going to go over what a parallel circuit is. So both of these two are the most common types of circuits that you're going to be able to see. And this is basically what we're going to be covering inside of this video. So let's get started. So first of all, what is a circuit? So here's an example of a diagram sketch circuit. And we're going to explain more about this in a little bit. So first of all, a circuit provides a continuous pathway for charges to move. A circuit must be closed for electricity to move. For what we just said here, we just said that a circuit provides a continuous pathway for charges to move. So basically what happens here is that we have a battery here, and we have, let's say, a lamp here, and we have a switch here. And basically what happens is that the battery provides the flow of current. So furthermore, here is a basic circuit diagram for a simple circuit containing a battery and a light bulb and also a switch. So now let's talk about the circuit elements. So even the most complex circuits are made up of only 4 basic elements or 4 types of components. So once again, we have our same diagram here. And what are the 4 components here? So the first one is the control or the switch. So here we can see that the control or switch just opens or closes the circuit to allow the electricity to flow. The second most important component is the source, which is whatever it is. So in this example, we have the battery. Sometimes it could be a cell or other types of battery source you have. The third one is the conductor. So the conductor is basically the wire that connects everything. And the most common type of conductor that you're going to have is copper wire, but there are also many different metals that you can use conductor for the wire. And the fourth component is the load. And this load, in this case, we have a light bulb, but in other cases, you could have, for example, like a toaster or a refrigerator or other types of components. So now let's go over what the flow of current is. So in this simple circuit, the direction of the current is from the positive terminal of the battery to the negative terminal, and this is called conventional current. So here is our simple circuit. So what we're going to learn here is just about the flow of current. So what we're saying here is that the direction of current is always moving from the positive terminal of the battery, so from here, and it moves all the way to the negative terminal of the battery. So current always goes from positive to the negative. And this is also called as conventional current. And can you guess what is going to be for the flow of electrons? And the flow of electron is exactly the opposite. So the flow of electrons is the opposite of the direction of the flow of electrons, which means it goes from the negative to the positive. So our current for our current, it goes from the positive end to the negative end, and for our electrons, it goes from the negative end to the positive end. And these are just 2 simple rules that we have for the flow of current. So now let's talk about the 2 types of circuits. And so there are 2 main types of electrical circuits, and the first one being is series circuit, and this is an example of how a series circuit looks like. And the second one we have is the parallel circuit, and here's an example of the parallel circuit. So we can see that the series circuit looks so much more simpler, and the parallel circuit looks a little bit more confusing compared to the series circuit, but we're going to be explaining both of these to get a better understanding. So let's start off with our series circuit. So here's our diagram once again. So let's see. So series circuits. In a series circuit, the components are connected one after another in a single loop. So if we look at our series circuit here, so we first have our battery there, and then we can see that all of these are called resistors, or we can have loads there such as light bulbs or refrigerators or whatever. All of them are connected together in a single loop. So you can see that they're all together in the same exact wire or the same exact loop. And in a series circuit, the current only has one path to follow. So we can already tell that there's only one path to follow, which is from the positive to the negative. And also, if one component fails, the entire circuit is disrupted and the current stops flowing. So this is the big disadvantage of series circuit, And the disadvantage is that if one single component of your circuit fails, then basically your whole entire circuit is going to start failing. So for example, let's say that we had a light bulb here, we had 3 light bulbs here. So instead of these resistors, we had 3 light bulbs. And let's just say that this light bulb just died, so we don't have a light bulb there anymore. So what's going to happen is that it's going to affect every single other light bulb here, so that nothing's going to work because the current is going to stop flowing. So this is a huge major disadvantage about series circuit, and that's why we've also created a second type of circuit, which is called the parallel circuit. And this parallel circuit solves the problem that we have in the series circuit. So this is how the parallel circuit looks like, and we can see just from looking at the picture, there's different directions that we can see that the current flows in. So in a parallel circuit, the components are connected side by side, so we can see that. And with each component having its own individual path to the power source. So we can see here that every single one of these have their own separate path compared to the series circuit. So in the series circuit, we had everything in one continuous path, but here in the parallel circuit, we have the battery source here. We go up, and then each single one of these loads have their own single path. And what is the advantage of this? So in a parallel circuit, the advantage is that if one component fails, then the current can still flow through the other components, as they are not dependent on at each other. So let's just say that the current was flowing through, and let's just say these were all light bulbs once again. So let's say the current was flowing through here, and this light bulb starts working. Then what's going to happen is that it's just going to stop working here, but these 2 light bulbs are still going to be on. So this solves the problem of having the series circuit, which the series circuit just completely closes the whole circuit, but the parallel circuit is still going to keep running. So that is a huge advantage that the parallel circuit has compared to the series circuit. And that's basically it for the 2 types of circuit, which is the series circuit and the parallel circuit. So now let's talk about the rules that are inside of a series circuit. So here is our series circuit once again, and these are our 3 rules. So basically what the first rule is, we're going to start with current, which is the most easiest to understand. So current, we're saying that the total current throughout the whole series circuit is going to be equal to each other. So what we're saying is that we're first representing as each one of these loads or resistors as I1, I2, and I3. So this one up here will be I1, this one will be I2, and this one will be I3. So basically here, the current that passes through each single one of these resistors are always equal. So that means I1, the current in I1 will be equal to the current in I2, and that current in I2 will also be equal to the current in I3. So that is our first rule of the series circuit. Our second rule is about voltage. So for voltage inside of a series circuit, what we're going to do is we're going to be adding them all together. So for V1, so V1 voltage in this one, we're going to be adding that with voltage for V2, and we're also going to be adding that for voltage of V3. So that is the second rule of the series circuit, that the voltages, you're going to have to add them all together. And for the resistance for the total, so we're going to say this is R1, R2, and R3. The resistance, we also have to add them all together. So for the resistance of this one, for R1, we're going to add that with the resistance of R2, and we're also going to add that with the resistance of R3 to complete the whole resistance that the series circuit has. So these are the 3 rules for the series circuit. And now let's go over the rules of the parallel circuit. So here's our parallel diagram again. So these are our 3 rules here. So let's start off with voltage first. So the voltage inside of a parallel circuit is going to be all equal to each other. So we're going to name this one V1, this one V2, and this one V3. And all we're saying is that voltage is going to be equal. So this voltage is going to be the same as this voltage, and this voltage is going to be the same as this voltage. And this is because if you were to measure from here to here and all 3 of these, the voltage is all going to be the same. So that's why we have voltage. So V1 plus V1 is equal to V2 and is also equal to V3. So in the parallel circuit, voltage is all equal, and then the current is not equal, as we saw inside of the series circuit. But what we have to do is we have to add up the current, because we can see that here in the current, we all get distributed. So since we're getting distributed, we have to add them all together to get the total current inside of the circuit. So all we're doing is we're doing I1 plus I2 plus I3, and that's how we get the current. And this could also be so on depending on how much resistors or loads you have inside of your circuit. And finally, for our resistance is equal to 1 upon R1, so this one will be 1 upon R1, and then we also have to add that with 1 upon R2 and plus 1 upon R3. So the resistance, all we have to do is add those three together. For the current, we have to add all those three together. And for the voltage, it's all equal inside of our parallel circuit. So these are the rules for our parallel circuit and also for our series circuit.